I've decided to do another one because the one I just did was extremely short and pretty easy. So this one I'm just found online somewhere, so exact same but a very peculiar rule set, which I will start reading now. Normal Sudoku rules apply. Shade the grid according to the following rules. All odd digits are water and should be unshaded. However, I'm going to make them blue just so it visually looks better, because water's blue, but you know, water's really clear. It's just the reflection of the fucking atmosphere. Water's blue. All even digits must be shaded to form islands, which I think I'm going to make green or orange. Haven't quite decided yet. All water cells must be orthogonally connected, but there cannot be any 2x2 areas of water. And orthogonally is adjacent, pretty much. So all water digits have to kind of be connected like that, and there can't be any 2x2 like this. An island is formed of orthogonally connected cells, again adjacent. Islands cannot touch each other orthogonally, but they can touch diagonally. So if there's an island here, there can also be another island here, but there can't be another island like that, because that would be connected. Digits may repeat on an island. A cage cell is representing the leftmost cell in the top row of an island. So there's an island that this is the leftmost cell in the top row. Right, okay, so the island can go like this. But since that's the leftmost cell in the top row, that works, okay. And of an island, and the clue on the cage cell is equal to the number of the digits on the island. To the sum of the digits, right. So all these digits on the island must sum up to 44. Not necessarily all cages are given. Okay. Feel free to pause, read over the rules. I'll put them in the description because it's taking my head a second to get my mind around it. Okay, so all odd digits are water and all even digits are islands. So let's just start with that. So we all know this is water and this is land. Actually, and we also know all these are land as well, because land is even. Okay. We can only have 4 evens in a box, and we already have 3. Whatever I put here will not sum up to 18. So we know one of these has to be the other orange. So we'll mark it like that. Because either one of them's orange. That means we'll have our 4, which means these 3 are blue. And odd. Now we can probably figure out this 18. 8 plus 6 plus 4 is 18. So this one, we know this island has to be the 8 plus the 6 plus the 4. We already have the 4. So this one here must be the 2 then. Right. Okay, well, obviously this island must continue to there. Actually, so then we know these can't be island, because then this wouldn't be the top leftmost cell in the top row. Yeah. So on the top, we know all of these are actually water, which is quite handy. This island could be 1, couldn't it? Okay, this is head my head. Okay, well, there's the 2x2 rule. There cannot be any 2x2 areas of water. So this would, if that was water, that would be a 2 by 2. So that's probably orange. Can an island be by itself? Can there be a one-cell island? I guess there can be, can't there? Okay, this is kind of the same as 18, so these two have to be island. As if there was one here, that would be the top left, that would be the leftmost cell in the top row. And then so we know these are water. And this also has to be our 2, 4, 8. No, not 2, no 2. 6, because that's how you get 18 with 3 even numbers. And that means that this is our 2. LG very easily could have gotten by the actually saying 2 in the top left. And we've got our odds down here. Okay, where to next? Well, we know that both of these can't be. No, they can both be islands, can't they? Okay, this 60 is interesting to me actually. Because the 2, 4, 6, and 8 add up to 20. Right? 2, 4, 6, 8 add up to 20. So we pretty much need 3 boxes of evens. Can we go down here and get 3 boxes? We can get a box here. Bit of a box there. Plus. Okay. Can I say that those two are both water? No, I cannot say that at all. Because they could be land from the one above. And then this could escape out here to fill this box like that. Okay, this one's going to be water no matter what. Right? Because if that's water, that's the land to ruin this. 4 by 4. And if that's the land, that's water no matter what here. And this has to be the water or land. One of the two. We also know that only one odd number is here. And we know both of these can't be. Actually, no, this up here makes it that land. Because that's would make it 2 by 2 then. Okay. This one's, at the moment, it's not much Sudoku, it's more like a, I don't know what it is. Ooh. Okay, so that is water. These four all have to be even. Which still works. I don't see why that doesn't work. Actually, we know this is land because that's a 2x2. And then that means that's water. And we know nothing. And both of those can't be land. Otherwise, that would. Oh no, it wouldn't, because we can still get out over here. An island is round. Can islands be one by one? I'm just gonna have to assume they can. There's a. Ooh, okay, that's real nice. Okay, so let's say this is land. We'll mark it red. So anything with the red, we're hypothetical land. And we'll make yellow hypothetical water. So that's hypothetical land. We've already got our four lands in here, so that's hypothetical water there. And your last two lands have to be here. And then we've already got four in a box. So this would have to be water. Not water. Hypothetical water. Which means. So if that's land, then this has to be. If that's land, that has to be hypothetical water. If that's hypothetical water, this has to be hypothetical land. And there's still exits for this water to get out of there. That is extremely annoying. We've got land. Okay, that's a shame. We're just going to have to remove all these white, yellow, and reds. Okay, we know there actually has to be an orange here, because otherwise this would be a. Just not mark that. There's no point marking that, is there? So we know there has to be an orange in one of these two. But we could have an orange in both, which doesn't really help. Okay. So let's say this is orange. That can't be orange. Because otherwise it would create 4 wars. 4 there. If that's blue, that can be orange and that can be orange. This is very confusing. Okay, let's just play hypotheticals again. Let's say that's hypothetical red. Which means I've got our 4 reds here. Which means these 2 are hypothetical water. Now this actually means that that has to be a hypothetical red, and that has to be a hypothetical red. Hypothetical land. And that means all these are hypothetical land. Which means all these are... No, that doesn't mean that. We've got 1, 2... We need a third hypothetical land in here. Okay. From here... What's the next step? Okay, so how's now this water connecting over here? It can't go out through here, because obviously it can't go down here because we still need a red. So it can go like that. No, it can go like this. And 2 with our reds. 2 box with this 60 won't work. So this is water. So this works. This has to be water. And then this has to be water. So we can get out and connect over here. We don't actually have to get out and connect over here, because we can go up. Because now that... No, so then we don't have enough land in this row. That's right? Unless we have both land here. And water comes up here. So no, both land here would make that water and make that land, which means that you can't have water here. So are we trying to prove that this cannot be land? Is that what we're saying? Okay. So we're saying if this is red, this is how this has to play out. Okay. So now this water has to come out. So can the 3 water come out over here? No, because that would place 2 reds here. Let's just color it. So the water, can we come out this way in this box? Going double hypothetical here. No, so this would then hypothetical water, and to make this work, that'd be red. And this water is trapped. So that actually doesn't work. And we already proved that the water can't come out here, because it can go like that. And 2 boxes isn't enough to get us to 60. That can only get us to 40. So which means this has to be water, and this has to be water. To actually get the water out. And that doesn't work, because now we only have potential 3. So that means that this doesn't work. So this pattern down here does not work. Which means, and we've got this pattern by putting a red here, which would make 2 waters because of the 4. Filling out the rest of the reds, and then the rest of the red. Yes, that can't be land, that is water. That is pretty techy. Which obviously gets us a land here because of the 2x2 rule. Now there's a good chance both of these are land, but we cannot confirm that. Okay, we know there has to be a water here, because if this is the land. So we can still place 2. But these both can't be water. Actually, no. This 20 means we have to find 3 digits. Right? To get to 20 we need, yeah, the 6, the 8, and yes, we need 3 digits, right? We need the 6, the 8, and the 4, which means that's the 2. Which we actually could have. So we need the 6 and the 8 and the 4. Which we could go like that, or we could go like that. Either way, that's water. Because those 3 are the land, or those 3 are land. But now since that's water, that has to be land. And since we need, yeah, so that now has to be land to make this work, and that has to be the water. These four here make that the water, making that the land, making that water. Actually, so now know this is the 4, 6, 8, where the 4 can't go there. Let's just make sure that the wrong numbers are turned off. Tools, visual gameplay. Check on finish, conflict find it on, check pencil marks off, mark self digits on. Okay, cool. Okay, so this water's all escaping. It's all orthogonally collected. Adjacent. Adjacent. I just can't be bothered trying to say that other word over and over again. Okay, well that's water now. And then that has to be land for the 2x2 rule. We get our 4 land up here, so that has to be water. That has to be land, and that has to be land for that 2x2 rule. And these 4 now have to be land to get the 4 in that row. And we know there has to be 2 water here. Actually, we know that this 2 here makes that the 2. And those 2 would make that the 2. Means that's land, making that the 4, and that the 8 for this row. So we need 1 land here and 1 land here. Because this could end and that could be connected down here, couldn't it? Some way. And then we have to, let's just mark 6 and 8 in here. Nope. Like that. There we go. We know one of these has to be water. Okay, if that is water, And we can't just use these two, so we have to use this. Which means that would be water, because we 1, 2, 3. Yeah, so actually we need to connect down here somehow. So not there. And then we can't be like that. Or we could be like this though. And connect to there. Or like that. Well, either way, this has to be red. With this hypothetical. Which means these two both can't be red now. So that, which means neither of those two, because if one of those red, we actually need to have the other one to connect. So then it would be like this, and connected like that, and then yellow like that, which doesn't work. Let me run through that, just to make sure that I'm not making a huge mistake here. So the 60 has to come down. Could come down there. But the 60 has to come down to connect to this big patch somehow. Otherwise, we can't make 60 with just these two squares. So our hypothetical is if this is water. Which means that is red land. And we've only got 3 land here, so we cannot connect down here. Ooh, no, if that is water, even easier, that has to be land to solve this row. And now there's no way of connecting that island, because it has to be adjacent to get to 60. So that can't be water, so that is land. And that's actually water now. And this can't be land, otherwise that's water's trapped. So like this. And this water has to come out. Escape. We need 2 land over here. Actually, no, we don't. Let's just do a bit of maths now. So this is going to be a 4, 6, 8. So that's 20 here. And we'll have another 20 here. So for our last 20, will come from inside this box. Actually, so that means that has to be land. Which means that has to be water. And then either one of those two has to be land. Which means that's water. So you know that can't be, let's just clean up these, that can't be 8, that can't be 4. Why are these blue? These should not be blue. Those should be land. Actually, so no, that's land now, actually. Okay. Let's start filling out these. This has to be 4, 6, 8. Obviously can't be a 4. This 3 means 3 has to go here. Not like that, maybe that. That 3 means that 3 has to go up here, and that 3 moves out that. Okay. Because we can do the same for 9 down here. So we know this is actually now a 3 9 pair. Now last two numbers are 1 5. 9s make this a 9 in here. Oh, 1 5s both don't see that, which means 1 5 can't go there, nor can a 9, nor can a 3, so that has to be the 7. Because remember, water is odds. Can this be land? I'll ask the question now. Okay, 44. So we have this whole box, that's 20. Actually, no. But yeah, so let's say this is 20. So I actually need to escape down into this box and use this box. That's 20. Plus, what can we get from here? 14. 44. Plus the 4 in here. Gets us to 44. Right? Because we still need to... This counts to here. Or whatever. And so if we get... Let's say it would have to be those four. That would be 20. Plus 14 from 6 and the 8 is 34. Ooh. So we don't have to use. So then we have to get 10 from this. But that has to be land, right? Because then we can't get down into this box. Which makes that water, and that is 6. And moves a 4. The 6 from down here. It's a 4 there. Don't like how it's not removing it for me. And then this has to be, because we need it. Oh, we don't need to be connected, do we? Actually, no, if that's land, that has to be land. That has to be, that can't be land. That's land to get the 4 in this row. I don't like how the highlighting works. That's land. We need land in here, which has to go there, and that would trap a water in that, so that has to be land. That has to be water. And then we can't have the lands connect, so that has to be water. That has to be land. And these two islands cannot connect. So that has to be water. Which means we know this is a 4. 4, 8. So we need 4 oranges in this box. We need 2 in this row, 0 in this row, and 2 in this row. If we can't have 3, we could have 3 up here. No, we can't, we only need 2 up here. What's this? 20, 34, so we need 10. We have to use those two to get 10. And that's the 2. We only need 1 in this column now, so that has to be orange. Need 1 in this column. Okay, we've got our islands marked out. Let's fill them all in with their possible digits. These 3 can be all 2, no, 4, 6, 8. These can be 2, 4, 8. This can be 4, 6, 8. And this can be all of them. This can be 4, 6, 8. So we know the 2 has to be here, the 6 has to be here, and the 8 can be anywhere. Yeah, so since we know there's a 6 here, that can't be a 6. Since we know there's a 8 can be anything. Also, hey, I just don't like this. Why is it not highlighting everything for me? Okay, where's the 2 going in this box? This is 6, 8. That has to be a 2. Which means that's not a 2. Where are my 2s? Okay, our 2s are stuck in our X-wing. I like calling X-wings like these things, where it's like a square. 4s. Okay, let's just do these odds, because I'm drawing blanks. No, there's a 7 up here. We know there's a 1 down here, which makes that a 5 and that a 1. We know that that's not a 1 actually. No, one of those has to be a 5. Because this top row, also know one of those, so this has to be a 3, 5 pair. Which makes this a 7, 9. Which makes that the only number we don't have, which is a 1. Now this is 7, 9. So that's the 7. That's the 9. That 7 means that this is a 1. And that's a 7. That's a 5. So now this is a 9, 1. Which makes that a 5. The 1s, rule out those. So we know there's a 1 here. Where are the other ones? So this is the only spot a 1 can go in this row. Makes that a 1. Okay, now we've got another X-wing with these 1s. Okay, whatever number's here in this box has to go up there. So therefore, and we know a 3 can't go there, which means a 3 can't go there. So that's a 9. And that's a 9. And that's a 3. Which means one of these is a 3. And one of these is a 9. Which means this is a 3, 9 pair. This is 5, 7. Obviously that's now the 5. That's a 7, because the 7 above. Which is this now at 3, 5, 7. That can't be the 3. That can't be the 5. Actually, this 9 means that that can't be a 9. That's the 3, and that's the 9. Which means this has to be either a 3 or a 5. And this now has to be a 7, 5 pair because of the column. Which means that can't be a 5. So that's the 3. That's the 5. That's the 3. Last odd is a 9, which means that's a 1, that's a 9, that's a 1 now. Now that's a 5, 7 as well. And now this is now a 3, 5 for this row. That means that can be a 5. That's a 3, 5, that's a 9. That's a 7, that's a 9. That's 7 means that that's a 3, that's a 7. That's a 5, that's a 3. That 7 means that that's a 5, and that's a 7. Okay, the odds are done. Which means these evens should be able to solve. Which is not really jumping out at me at the moment. This shouldn't be this hard, so I'm just missing something pretty big. Okay, these 4s, so we know there's a 4 up here, and we know there's a 4 here. Four can stick it anywhere in this box, man. So now I'm going to have to get out my hypothetical coloring again. There's no way I'm having to do hypothetical with these evens. I'm determined to find it without using hypothetical in my special colours, but, you know, I don't want to be sitting here all day. Okay, maybe we don't need hypothetical. Because what's ever there has to go up there. So these are the same. So these are both green numbers. And if that's a green number, that is also a green number. Because if that's there, we need a green number in this row, which would be there. Oh, could be a 4, couldn't it? And this 4 could be there then. And then in this middle row now, that would be a green number. So we concluded green is not 2. Does green not align with anything now? Okay. Green means that neither of these two can be green. Okay, let's just make these a different color. Oh yeah. What's the next step? Okay, we know that these two are the same color. These two are both, let's say, red. Because whatever goes there can't go there. Which means this is our third color. Let's go yellow. And then this has to be the yellow one. You know, yellow could still be this one. Oh god. Okay, I'm just gonna redo all of these pencil markings because I cannot be bothered. Get rid of all these hypothetical colors. They're still orange though. Let's go to 2, 4, 6, and 8. Okay, this has to be 6, 8. This has to be 6, 8. This has to be 8, 4. Oh, this has to sum to 44. Like, what the fuck am I doing? What am I doing? Okay, 20 plus 4. So this has to be the 8. There we go. That kind of probably solves the whole thing for me. I bet. 8 can't go up there, so the 8's there. That's the 6, that's 4. 8 goes there now. Make that a 4, that an 8. This is pretty much solved. That can't be a 4. This is either 2, 6. This is 4, 6. And this is now 2, 4. This now has to be either a 2 or a 6. 2 can't go up here. So we know a 2's done. So that can't be a 2. So this is now has to be a 4 or 8. Whatever's there has to go there. So that's either a 4 or 8. This can be 4, 6, or 8 still, I think. This has to be now 4, 6. And this has to be... This can still be 2, 4, or 8. Okay. This feels like we're stuck. Because we have our x-wing of 2's here. Oh, look, that can't be a 6. That's the 8. Is that the 4? Makes that the 2. Makes that the 6. Makes that the 4. Makes that the 6. Makes that the 2. Makes that the 8. Makes that the 4. 6. 8. 6. There we go. 50 minutes. Those evens, bro. I just completely blanked. Solve counter. Who the fuck knows what that means? Yeah. That was. What are we gonna call this? Dodekanesos. Yeah. 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 Cool. That's been that.